Hi everyone, welcome back to another video. So today we are going to look at DynamoDB, and this is going to be first part of a two-part series where we are going to talk about just DynamoDB. In this part we are going to go into fundamentals of DynamoDB, what it is, why it's there and how it works, and then we are going to deep dive into some of the important topics and concepts that everyone should know about DynamoDB if they are looking for modeling applications with DynamoDB. So without wasting any time, let's start. So let's cover all the things that we'll see in this video. The first thing is we'll see the introduction to DynamoDB. Second, DynamoDB properties, where we will see its data modeling form, its connection model, and CDC, which is capture data change. Then we are going to look at DynamoDB core concepts, where we are going to talk about terminology, primary key, and then secondary indexes. And then we are going to look at the pricing model that DynamoDB uses, so that you are able to calculate how much it is going to cost you and what operations are expensive in DynamoDB and what are cheap. Okay, so let's start with the first thing. So let's talk about what exactly is DynamoDB. Okay, so DynamoDB is a fully managed NoSQL database provided by AWS. Okay, so it's a NoSQL database. So as you all know, that there are two types of databases. One is relational and other one is NoSQL. These are the two popular database classification that we see. Now we have a lot of different NoSQL databases. For example, Cassandra, we have Elasticsearch, and we have MongoDB. So similarly, now DynamoDB is also a NoSQL database that is given to us by AWS. Okay, but it is fully managed. So that means we don't have to take care about anything. We just create a new table in the DynamoDB in the AWS console and we just start using it. We don't care about how it is partitioned, how it is sharded, how the data splits between things, how consistency is managed. We don't have to care about anything. We don't even have to care about scaling it. Everything is managed by AWS. Okay, and since it's a NoSQL database, that means we don't have any strict schema. It's schema-less. We can put anything we want and however we want it. Okay, so that is what DynamoDB is. Okay, so what are its properties? So first property that we are going to look at is data model. The DynamoDB data model is divided into two ways. One is key value, which we all know is just key which points to a particular value, and second is wide column store. Okay, so let's understand what these are. So key value, so we have a key against a value, just like a hash map that we have all used. So if we have a name would be Sarthak, age 25, simple as that. One-to-one mapping, no complexity, so that when you want to pull something, if you want to fetch the name, it's very fast to look up. Okay, now what is wide column store? So wide column store uses B tree to index everything. Okay, so it is not a one-to-one mapping, it is one to n number of mapping. Okay, so let's see this. Let's say that we have this data where this office 1 is one key part. Okay, then this customer 1 2 3 4 is another key part. Okay, so let's call this 1, let's call this 2. Okay, so now together they make a key. Now part 1 plus part 2 equals to full key. Okay, so wide column store means that instead of just one key, it has been widened into accept more parts into the key. That's why it's called a wide column store, and it is a B tree. So for example, for this particular example, this would be a parent node and this would be the child node, and this and each child node will contain its appropriate data. So this is heavily used for range queries. Whenever we want to do any kind of range query in DynamoDB, we use the column-wide data model is used. Now there's one important distinction. Unlike Cassandra, which is also a column-wide distribution of a data model, DynamoDB has been officially categorized as key value. Even though this is true, it is officially called as key value database. So keep in mind that. Okay, so now let's move on to the scaling property. Now DynamoDB can virtually be scaled infinitely, okay, without any performance degradation. Now what does it mean? What performance are we talking about here? So when we talk about DynamoDB, why it is so popular than other NoSQL databases is because of its response time. It's very fast. So when you use any DynamoDB, let's say you have 10 entries, only 10 entries, then also you get the response time as less than 10 seconds. It is called a single digit response time because it is less than 10 seconds and it's super fast. Now let's say from 10 you get 10 lakh entries. So then too its response time is going to be single digit response time. Now that's why we say that DynamoDB can be virtually scaled infinitely and without any performance degradation. Of course, when you scale infinitely, when the base becomes so big, then there are a couple of bottlenecks that we face, but DynamoDB is built such a way that you are not going to run into those issues and you are going to get very good performance out of it. Okay, so but what if we are running into that issue and we want even better performance? Then we use something called a DAX. Now when you work with production databases, this is something you will often hear. It is called as DynamoDB Accelerator. It is a fully managed in-memory cache for DynamoDB. It's an in-memory cache that sits on top of DynamoDB and gives you even better performance for large-scale systems. Okay, so now let's talk about its connection model. So DynamoDB uses HTTP connection model. So HTTP protocol is used to interact from client to DynamoDB. Now what exactly is special here? So we know that most of the things on the internet works with HTTP protocol. When you go on any website, let's say www.youtube.com, so it's an HTTP protocol only. This is HTTP protocol only. So what's so special about it? So most of the databases, for let's say relational databases, they create a TCP connection pool. They create a TCP connection pool. So what it does, it creates a number of connections with that particular database, which is always occupied for the database operations. What happens when, let's say that you have a lot of database calls, then if there are not enough connections and if the database is taking a lot of time or there is a bottleneck in those connections, then it hampers with the entire system. And it gives you bad performance at your service level, service layer. So DynamoDB does not have that. Okay, so for client to DynamoDB, it uses HTTP protocol. So basically, DynamoDB client make API calls directly to AWS DynamoDB. So it's a get post request, the RESTful APIs that we normally use, and there is no TCP connection pool. So the only connection pool exists is the one that is created for the HTTP calls that we are making from the service. Now this gives us the potential to virtually unlimited parallel calls. So as many connections as we can have for the HTTP, we can send it to AWS, and AWS will give us. Now you might ask, AWS gives an SDK. So how is it not a managed TCP connection pool? Because that's what we expect here. But thing is that the SDK internally has AWS APIs, which is get, put, delete, etc. So these are the APIs that are inbuilt inside of this AWS SDK. So we don't have to care about all of these things. We just tell what the identifiers are for our table, and we just start to use it. Okay, so now on to the next one. DynamoDB is also so popular because it has flexible pricing models. So what pricing model does it support? So there are two pricing models. One is provision. Okay, we are going to talk a lot more about this provision at the later part, where we are going to actually talk about its pricing model. But provision in short is basically we have to pre-allocate the resources for the DynamoDB so that we know how much it is going to take. We know that 1,000 users are going to come every minute, so we just scale it at that point so that it can handle 1,000 users. Okay, now the next one is on demand. On demand is when the DynamoDB automatically adjusts itself and is able to handle the traffic by scaling up or scaling down depending on the current traffic. So let's say that out of 24 hours for the first 10 hours there's no traffic, but then there's a spike in traffic till 11 hours. So then it will automatically scale itself, and on the 12th hour it will just come down since there is no traffic. So you only pay for this hour, you don't pay for this or this. So out of these 24 hours you are only paying for 2 hours. So this is how the DynamoDB works on demand. So it scales as per your traffic. Okay, so let's say that as we saw, this is the scale, and DynamoDB is currently here. We have kept it as per the traffic. So this is traffic 1, but then again traffic kept on increasing. Since the traffic is increasing for traffic T2, the DynamoDB will scale itself. Now let's say drastically the traffic got down to the original level. Maybe it was peak hour, it was some sale, and now that is over. So then the DynamoDB will scale down itself to save you money. So you are not going to pay for this, and you don't have to manually scale or manually downscale the DynamoDB. So this is very beneficial for the on demand. Now provision is something we are going to look at in more detail how it works. Okay, now the fifth property is CDC, capture data change. So if you have ever worked in production systems, you would know that all the data that we are putting inside of DynamoDB, it should be available in data lake or data warehouse, so that analysts can use it to study the data, analyze it, and have a backup. Or let's say we want to audit that data. Now for that we create a capture data change pipeline. So it is very easy to do that using AWS, because AWS gives something called a stream. These are streams. So what happens that every put request, which is create or update, these are the two operations that we can do on a database when we are adding new data. Or let's say delete. Okay, these three operations, whenever we do it, this gets transferred, this gets exported from something called as streams. So it is just a continuous flow of data where the as soon as the changes comes, the data keep on flowing. If there is someone listening to it, if someone is listening, then the data will go there. But if no one is listening, then these updates will go after 24 hours. Okay, so what we can do is we have a data DynamoDB that writes the data. What we can do is for the data that are coming out of stream, we can connect a lambda to it. Now what will that lambda do is write all of the changes into an S3 bucket. Then this S3 bucket can be exported to data lake or data warehouse, so that every change that we are having on this database gets audited and gets saved on analytics to study that data, or just for the audit purposes. We can do that. Okay, so these were all the DynamoDB properties. Why, as to why DynamoDB is so good and why it is used across industries. Now look at some. Let's look at some core concepts of DynamoDB. Okay, so first we are going to talk about terminology. So what you are seeing here is basically a DynamoDB table. I have created a short representation of the table, how DynamoDB table looks. So it has a lot of things. So first of all, this table we are calling it users. Okay, so it's a user table. Now it has something called as primary key. Okay, now what is primary key? Primary key is something that uniquely identify a row inside of a particular table. Okay, so if let's say we take this example, now this is the primary key. Okay, so it has user 1 and warehouse 1 as part of primary key, and then we have these are the attributes. So in DynamoDB we have primary key and then we have attributes. Okay, but in relational database we also have primary key, we have foreign key, we have primary key, we have foreign key. Here we do not have foreign key. Here and instead of columns we have attributes. Okay, so let's take one item, and relational database we call them rows. Here we call a single item. So let's say that we have one item. In this item, user 3 and warehouse 2, this is a primary key, and name, domain, email, these are attributes. And the name, exactly, if the let's say name is name 5 or name 3, domain is marketing, email is XYZ, these things are values. Okay, so we have one item inside of our DynamoDB database. But DynamoDB also supports an item collection. What is an item collection? Item collection is a group of items that correlate to a single part of the key. Okay, so let's look at the primary key. Okay, so if we look at the primary key, a primary key is a unique key in the table to identify a row. Okay, so we have a simple key, we have a composite key. Now simple key only has partition key, composite key has partition key plus sort key. Okay, we'll come back to this, but basically in the terminology we have a primary key that uniquely identifies a given item. Then we have attributes that are the data with this key. So this will be the key, this will be the key, and attributes will be the values. Okay, and a single item, basically single partition key to sort key is single item. But if we have one partition key and have multiple sort keys, then that becomes a item collection. Okay, so now look at some now we'll look at some of the attributes. So there are three types of attributes in DynamoDB. One is scalar, complex, and sets. So scalar attributes are basically integer, string, booleans. These are primitive data types that DynamoDB supports. Okay, then we have complex data types. So complex data type the attributes includes list and map. Now this complex attributes are made up of these scalar attributes. Okay, then we have sets. So we have two types of sets. One is number sets and then one is string set. This is altogether a different type of attribute, and it is not scalar, but it uses scalar values. So the data type is not the scalar one for this set. This is number set itself. This is string set itself. We also have bool, but we don't have a bool set. So And we have three types of attributes. Okay, now let's come back to the primary key. As we just talked about that, once we have a simple primary key, and another side we have composite. So simple is used for one-to-one mapping, and composite key is used for one-to-n mapping. So for an example, I have a partition key that is user 123. Okay, so I want to actually talk about this as well. A primary key is made up of either only partition key or partition key, I will call that PK, plus sort key. Now these are just names. Okay, these are just names, but it is just two things that create a primary key. So if it is simple primary key, it will only have a partition key that is user 123, because we don't need any other identifier to identify this particular item inside of a DynamoDB table. So user 123 is unique ID, unique user ID, and it has a lot of attributes, could be any attribute. Okay, but when we say composite primary key, then we have to we divide this primary key into two things. One is partition key and one is sort key. So partition key could be user. So this let's say table could contain user data as well as let's say devices data. So it could have device ID as one as well. So because since it is a user partition, this is a device partition, so it could have this. Since DynamoDB does not have a very strict schema, we can put anything and any schema and any data that we want. So hence the composite primary key, it is the most used one when we do actually data modeling using DynamoDB. But here the partition key is user and then sort key is one, and we can read it at that for the user partition with the ID 1 has these attributes. So this is how the composite primary key is built, and this is in general what how primary keys exist in DynamoDB. Now another important core concept in DynamoDB is secondary indexes. So for how DynamoDB works is that in DynamoDB while modeling you have to take care of fetching patterns. Now why is that? Why this is a thing here, why we have to worry about fetching patterns? Because let's say that we have a relational database, we have table 1, table 2, table X. So any data that we want, we can just pull it out of 2, we can use a join here, and we can get the result. But let's say tomorrow we want to get data from this as well, from these two, then we can use join here and then we can get the result. So the relational database is very flexible in terms of fetching data and having query patterns. But for DynamoDB this is not the case. Since the examples that we were talking about, since this is the key and this is the value, okay, I'll just write it here, this is the key and this is the value, so then you can only fetch through the key. Okay, for composite as well, this is the entire key, so we can only fetch through this. We cannot fetch that give me the user which has 25 age or above. Now if we do that, then the DynamoDB will scan all of the entries and then filter it out. Now we don't want to do that, because if let's say there are a million let's say there are a million entries, then I am going to read all million. I'm going to read all 1 million entries, and I don't want to do that, since that's inefficient and it is not going to give me response in a single digit millisecond. So I only fetch using the user, basically key. So if I will say that give me data for user 1, So but now this makes the DynamoDB very rigid. What if once I've implemented it, I want to now scale it and have different query patterns? Now I actually have the use case where I want to fetch based on primary age, let's say. So then that's why there's a concept of secondary indexes. What we do is that we create an index for a flexibility to fetch data through different ways. Okay, now there are two types of indexes. One is LSI and another one is GSI. LSI is local secondary index, and then GSI is global secondary index. Okay, let's look at both of these. So now in LSI, imagine these indexes is just as a copy of original table. Okay, remember this. So for LSI, we always have the same partition key, but we can have different sort key. Okay, so if this is the example and we want to create an local secondary index, then the partition key would be the user, but sort key could be Sarthak. So user Sarthak would be the new index, and I can fetch using all the data for user Sarthak instead of user 1. But when we create GSI, we are not limited to using the same partition key. We can use any partition or sort key from the attributes available. Now it should be from the available attributes only. That is important here. Okay, then another thing is it uses the tables provisioning. Okay, what is provisioning, how it works, what is WCU, RCU, we'll understand in the next segment of this video. But this basically says that whatever configuration you set for the table, okay, let's say that you want that only 100 reads to be done per second, then if when you fetch from the LSI, then they both will share this configuration that only 100 can be read from this table. But for GSI, different provisioning of RCU and WCU is required. So it will have actual table will have, let's say, 100 item per second. Now this can have 50 or 150 item per second. So this would be separate and this would be separate, so they won't get bottlenecked if they are queried at the same time. Now LSI could be either strong or eventual consistent. So let's say that there are X partitions, so we can let's say that we have a table and we have a LSI. We have a table, we have LSI. So then we can either choose that we want to write to this table and only return success when it has been successfully returned to LSI as well, and then only return. But if we want, we can have eventual consistent where we write into the table, okay, and then we return and then it goes to the LSI. This is the flexibility that we have. But when it comes to GSI, we only eventual consistency is available there. Now LSI, local secondary index, can only be created when we create the table, when the inception of the table is there. So you cannot create LSI once you have created the table and it is in production working, having reads and writes. Then we cannot create LSI. Then we can only create GSI. GSI can be created any time of the point, no matter it has 10 entries or it has 10 lakh entries. It wouldn't matter. It wouldn't matter. We can create GSI anytime we want. Okay, so now we are at the last part of the video where we are going to talk about pricing models. Now DynamoDB pricing works a bit different. Here the pricing is based on RCU and WCU. Now RCU is read capacity unit and WCU is write capacity unit. So if you saw above that we talked about that there are two modes of pricing models. One is provision, one is on demand. We talked about one on demand, but we said that we will discuss the provision later. So this is the time where we are discussing the provision. So to understand provision, you have to just see that all the reads are calculated through RCU and all the writes are calculated through WCU. Okay, so but what is one RCU? What is one read capacity unit? So one read capacity unit is you can fetch any data from the DynamoDB of 4 KB per second. Okay, 4 KB per second equals to 1 RCU. Okay, now this 4 KB per second is for strong consistent read. This is important because if it is eventual consistent, then we can have 2 entries of 4 KB, basically 8 KB of data per second. Now it could be included in multiple records, it could be included in one record. Generally it is in one record only. So that is what one RCU is. Now how it is costed? So a DynamoDB AWS, what does it? It will tell you that let's say for 10,000 RCU I am going to charge you $1. Okay, so then for every 10,000 RCU I will charge you $1. So this is how you can calculate what your cost is going to be, the read cost. Now similarly, one write capacity units is 1 KB of data written every second inside of the DynamoDB is 1 WCU. Okay, now let's see this in action. Imagine that you have to read 80 items per second. Okay, so to read 80 items per second, how much RCU is required? And each item is of 3 KB. Okay, now we are going to consider that we are doing strong reads here. So what we'll do is we will take the item size and divide by the unit capacity here, which is 4 KB. So 3 by 4 gives us 0.75. Now 0.75 we will convert it to the nearest whole number, that is 1. So that means for one 3 KB item I need 1 RCU. Okay, so for 100 item per second I am going to multiply 80 by 1, which is 80 RCU. So in order to read 80 items per second, then I need 80 RCU. But in production we generally bump the RCU by 20%. So if we add 20%, so good RCU to keep is 96 RCU, so that we are not going to get into trouble with any kind of throttling issues if let's say the throughput increases somewhat. Now for WCU, let's say that we have to write 100 items per second. Then how much WCU is required if the item size is 512 bytes? Then the calculation is the same. We will divide 512 bytes divided by 1 KB. So that gives us 0.5. Now we are going to round that off to the nearest whole number, which gives us 1 WCU. So in order to write 512 bytes, we need 1 WCU. Since we have 100 items per second into 1, that gives us 100 WCU. Same here, we will increment it by 20%, then we get 120 WCU. Okay, so this is how the pricing model of WCU works. Now what AWS, when you create a table, when you go to the cost page, what it will show you is for let's say 1 million RCU, it's let's say $1, and for 100 K WCU, it's again $1. So then this is how you can actually check that if let's say that you are having 100 items per second. Okay, and since you are writing 100 items per second and there are 24 hours, then 24 into 60 give us the second, then you can multiply it by 100. So it will give you how many RCU will be required to you, and let's say that RCU is required, and then you can compare it that if it is less than million, then you only required to pay $1, otherwise you are required to pay more than that depending on the final output. So this is the fundamentals of DynamoDB. I hope you are able to grasp what DynamoDB is about, and you are able to understand the fundamentals. If you have any doubt, if you want clarification on anything, you want me to go into detail on any of the things that we talked about, please let me know in the comments below. And if you like the video, please like and stay tuned for the next part where we are going to deep dive into some of the concepts and details for the DynamoDB. And as always, I'll see you later. Bye bye.